Hi everyone, welcome to a follow-up video tutorial for multi-animal pose estimation with YOLOv8. In a former tutorial, I showed how to analyze multiple animal poses with their bounding boxes and different pose estimations for body parts getting generated as text files. And in this video, I want to show some of the analyses that are possible and some of the follow-ups that you can do. So in my current project, I have, there are different body parts and they're paired XY, XY, but no other information is available here in terms of which body parts those are, whether those are the bounding boxes or other things like that. Okay, so in this video tutorial, what I want to do is basically go over some of the scripts that I have written here to help with the analysis. Let me go ahead and set up my environment here. Something like this. So this is specifically written for the example that I had in my former video. I go back here, I was analyzing this video. Okay, these are two flies. There's some chasing going on there. They're in different orientations. Their wings are kind of moving around. So what I did was I labeled the wings as one body part. So there was left and right wing. There is abdomen, thorax, and the head. For each of the flies. So fly M is the male fly, fly F is the female fly. So in this analysis, what I want to do is I want to take the output from that analysis, which was the text files, and I want to get some information out, such as what are the durations of the chasing behavior. One fly is chasing the other one. And when are they facing each other? What is the duration or count, the number of times that they're facing each other, for example. So that would be the frequency. So things like that, I want to just quickly demo so that you get a sense of, hey, a lot of things are possible with this type of YOLOv8 analysis. So on the left, I have my folder open where I have all of these labels. Again, they have two male and female flies with their respective pose estimations and coordinates for each body part. So what I'm doing here is I'm setting up the directory path. My directory path contains all of the labels that are generated, and I'm also assigning an output path. So the output path in my case is this predict folder. I've already tested this out and it works. I'm going to delete these CSVs and it's going to be generated again because I'm putting the CSV, this output directory, my body parts. So this is a little bit tricky. You have to name your body parts in the orientation that you assigned while you were labeling the body parts. So head for me was first, thorax, abdomen, left wing, and right wing. So this is the way that I designed my skeleton for the labeling. And I'm also setting a minimum threshold of 2 frames for detecting behaviors such as, the flies are facing each other. Here, behavior is used loosely. It may not be a behavior if they're facing each other, but I'm just defining it as such. And then also for chasing. So minimum frame numbers that those behaviors have to be done for my script to count them is at least 2 frames. Here I'm also using 2 body parts to be able to do calculations. For example, the direction that they're moving in. For example, I'm calculating the direction so I can understand if one fly is chasing the other fly. So if they're moving in certain directions within a given orientation, we can figure out whether they're chasing in chase behavior or not. And then here in this, I'm just calculating the speed. Right? That's a very easy thing to do. Distances are also being calculated. For certain behaviors, it's not appropriate to do calculations with orientation, but rather distance. For example, if you're understanding the mating behavior, your orientation might be opposite. So you might think that they're chasing each other, but that their distance is reducing relative to each other, so that you can assume to be a mounting behavior of some kind or aggressive fighting behavior, something like that. Okay, so distances are being calculated. I'm also detecting the frames during which these things are happening, right? So the output will have something like pointing towards, what's the frame count for pointing towards, chasing, what are the frame counts for the behaviors that are considered chasing, where one fly is orienting away from the other fly. And then, I'm just outputting the frames for the number of frames that those behaviors happen. So overall, it's a fairly self-explanatory script, and also I'm saving all of these extra information such as headers here into a CSV, and I'm parsing my text files like this here with X and Y coordinates, and I'm basically doing a data cleanup to set up my CSV files so they're easier to read. And I will show you what the CSVs look like with this script at the end. And that is being generated for both male and female flies in my case. So if you're using mice, for example, and you're keeping, the 4 body part system that I have in this tutorial, or what is it, 1, 2, 3, 4, 5 body part system. And by the way, this you can scale up to X number of body parts. It doesn't really matter, but going through this, you might have to change the some of the parameters. Might have to change a little bit so that it can work with your system. Okay, overall, the script itself is very, very easy to implement. You need to have matplotlib installed, NumPy, CSV, and the OS. You need to have these 4 things in your environment. So I'm going to go ahead and run this script, and within just few seconds, we should have our output calculated and CSVs stored. So here is an output that gets generated. So this is distance between flies over time. This is the difference of the distance between the flies. And I believe I'm using thorax here as a marker. Yeah, so I'm using the thorax of the flies as a point to take the distance measurement, distance between the flies, using the thorax as the example. And then on the top here, the fly directions over time, different frames, what is their orientation relative to each other. And for this, I'm using 2 body part systems, the head and the thorax, using those 2 body parts to do the orientation. And then in the terminal itself, it prints out the number of times the flies are pointing towards each other. It's 71 times, and duration of chase behavior is 55 frames. Average distance between flies is 0.31. Now, again, this right here is dependent on how you define the threshold for the calculation. So here, the minimum frames for detecting behaviors, this will be determined by what you set up over here. Okay, so and also what the frame rate is for your videos. In terms of the CSV outputs, the way that the CSV is generated, these 5 columns that get created, the frame numbers are here in column A. Then we have different body parts and their positions, X and Y, and then their confidences. So I'm skipping over the bounding box information. So if I take this X and Y frame 0 body parts and I just go ahead and plot them like this, for example, and from memory, I can tell you head is here. This is the thorax, and then abdomen. This was one of the wings, and there was another wing on the right side. This is the male fly. Okay, so this is just in a nutshell what you're able to get out, and same thing happens for the female fly. I just plot these out here. Female fly mostly has its wings folded in, flaring out. So this is what you're going to see over here for male fly. Or in my case, this is what I see. Okay, so that's it for this video. Leave a comment. Let me know if there's anything else I should do. I've created this script as a template. Basically, you guys feel free to modify this. This can be applied to not only flies, but other animals. So far, this is only meant to be for animals, but this can scale up. You have some experience with Python. You can scale this up to an animal if you wish. And it will all depend on your training data set and how good your trained model is at the end, be able to give you the differentiation between different animals. And for me currently, I'm using a very low number of training data set and very low quality of validation. So the behaviors are not very good. But in theory, this script should get the job done for most people who are interested in orientation of animals or chasing behavior and things like that. So thank you so much for watching, and give this video a thumbs up if you find this to be useful. Thank you.